Good afternoon, everyone. Today we're going to do a video on solving a definite integral with a U-substitution. So, whenever we're looking for a possible substitution, it is useful to look at a part of the integrand that we can substitute in for u, where the du part of it will also be very convenient as far as dealing with our integrand goes. And so, before we get into that, I'll remind you of a fact that the root of x can be written as an exponent in the form of x to the 1/2. And if we take the derivative of root x, then we take the derivative of x to the 1/2. And that's going to be 1/2 x to the negative 1/2, right? And another way of writing this is 1/2 times 1 over, because a negative in the exponent simply means 1 over. So x to the negative 1/2 can also be written as 1 over x to the positive 1/2, which can be written as 1/2 times 1 over, again, x to the 1/2 is simply root x. And so 1/2 times 1 over root x, and then putting it together, we can simply write this as 1/2 root x, okay? Now, that's gonna be really convenient in solving our integral, because we have a 2 root x in our exponent, and here we have a root x in the bottom, here we have a root x in the denominator. And so this is likely going to be a very useful substitution. We also have a 3, but this simply means 1/3 of this entire thing, and so we can move the 1/3 outside of the integrand, and so we really don't have to deal with that whole lot. So I'm going to go ahead and show you I think the most practical substitution in this case. I'm going to make a substitution that u will be the entire exponent, because we know how to integrate exponentials fairly readily. So I'm going to make u be 2 root x, okay? And if u is 2 root x, then du is going to be this. So if the derivative of root x is this, then the derivative of 2 root x is simply going to be 2 times this. And so if we have 2 times that, 2 times 1/2 root x, which is the result that we found here earlier, the 2's conveniently cancel out. And so all we have, I should add before I go any further, du is equal to that times dx. Let's not be forgetful. And now we have, in a simplified manner, we have 1/root x dx, okay? So that means that we can substitute in du for this entire thing, 1/root x dx. And maybe you're starting to see how that's going to play out. So now we can write this integral as the integral of e to the power of u, because e to the power of 2 root x becomes e to the power of u, so e to the power of u. And then the over 3, we can think of that as 1/3, and so we can move that outside because it's a scale factor, so it doesn't take any part in our x or dx integrand. And we have over root x, but 1/root x dx, 1/root x dx is going to be substituted in completely for du. And so all we're going to have is e to the power of u times du, okay? The only little note we have to be careful of is now the upper and the lower and upper bounds on our integral are now written in terms of u, okay? Sometimes we just kind of leave those in and plug them back in the very end, or we can make a u substitution. And so if x is 0, right? If x is equal to 0, which is what we have at the lower bound here, then u is equal to 2 times root of 0. And u is equal to 2 times 0, which is 0. And so we'll still have the upper bound being 0, but when x is equal to 3, we have that u is equal to 2 root of 3. We're just replacing the value of x by, we're replacing the value for x into the position of x in our u substitution. And so if x is 3, then u is equal to 2 root 3. And so our upper limit goes from 3 to here to root 3. Only because we're now differentiating with respect to u rather than respect to x. This is not going to turn out to be important in the final analysis, but for now, if we want to be proper, this is the right way to do it, okay? So now we can go ahead and evaluate this because this is fairly simple to integrate. We have 1/3 times the integral of e to the u, which is, if you know your exponential integrals, is just e to the u. So we have e to the u, and we don't have to do plus c because this is a definite integral. And so now we have 1 over 3 e to the u evaluated from 0 to 2 root 3. And if we want, now we can resubstitute in x in for u. And so we can also write this as 1 over 3 e to the u is 2 root x. So we can replace that back in and write it as e to the power of 2 root x. And then we can go back to our original lower and upper bounds on the integral of 0 and 3. Okay, we could have evaluated it at this point and gotten our value all the same. Since I'm sure you're used to plugging back your x variable values in, let's go ahead and do that. And so now we have 1/3 at the very front. And so that's easy enough to deal with. We can leave it at the very front and do the rest of our calculations inside of a bracket. So we have e to the power of 2 root x evaluated from 3 to 0. So let's start off with the upper limit of 3. And so we have e to the power of 2 root 3 minus, when x is equal to 0, e to the power of 2 root 0, which is 1 over 3 e to the 2 root 3. This is going to be an irrational decimal, so let's leave it as a radical. And minus, now that's e to the power of 2 square root 0 is 0, so that's e to the power of 0, which is simply 1, right? Is 2 to the power of 0. 2 times root 0. This 2 times root 0 is simply 2 times 0, which is 0. And so e to the power of 0, we know, is just 1. Okay? And now, to finish off our solution, we have 1/3 bracket e to the power of 2 root 3 minus 1. And it doesn't get much simpler than this because this would give us a horrible irrational decimal. This would give us a repeating decimal that goes on forever. And so I believe that this is the best way to finish off our solution. And we can write that our definite integral has the value of 1/3 bracket e to the power of 2 root 3 minus 1. And we can leave it like that, okay? So I hope this was helpful. I hope you're slowly starting to get some pattern recognition when it comes to U-substitution and what parts of the integral are the best candidates for a U-substitution. You're learning how to connect the U-substitution to the du, and in the fact that whenever you choose something to be substituted in for u, you have to think of how du is going to play out and how convenient the du is going to take care of everything else you need taken care of the integral so that you're actually able to integrate. And in this case, we see how much simpler the second line is to integrate. Always being careful of how our u substitution correlates to our upper and lower bounds on the integral, and then always plugging the values in carefully at the very end. And finally, we could write this as a messy decimal and round to a certain amount of decimals. However, this is an exact value, and so I always think that this is the best way to finish things off. I hope this was helpful. If you guys have any requests for future videos, please do let me know, and thank you so much for watching.